Okay, so today we're going to look at some word problems involving what are called angles of elevation and angles of depression. So an angle of elevation, almost everybody gets the angle of elevation part right. An angle of elevation is formed by a horizontal line and a line of sight that is above the horizontal. So it's a little bit like if you look straight ahead and then you look up, you know how you kind of rotate either your eyes or rotate your head upwards? That's an angle of elevation. You're elevating what you're looking at. Okay? Now, what students frequently, not everybody, but there are some students who get this wrong, the whole unit, and then they lose tons of points on the test. Don't let this happen to you. Is the angle of depression. Angle of depression is you still start off by looking straight forward, but then you look down. That angle is an angle of depression. The problem that people have is they tend to want to put the angle of depression right here because it's inside of this triangle. That is never, ever, ever going to happen. The angle of depression does not go inside that triangle. Whereas the angle of elevation, like if you're looking at something, you know, there's a triangle over here, and everybody is fine because it's inside the triangle. The angle of depression isn't in the triangle. But here's the thing. In any given problem, whether it's an angle of elevation or an angle of depression, just depends on who's observing. If someone on the ground is looking at something up in the air, it's an angle of elevation. If someone who's up off of ground level is looking at someone on the ground, it's an angle of depression. And here's the important part, because these two are parallel to one another, the angle of depression and the angle of elevation are always the same size. Because they're alternate interior angles made by parallel lines. So if you don't like angle of depression, you're like, I can't remember where it goes, well, just pretend it's an angle of elevation, because they're always the same size. All right, let's look at a couple of example problems. We'll just look at two. So, while walking in downtown Houston, James spots a dove on top of a building at an angle of elevation of 67 degrees. If he is 100 feet from the base of the building, how high is the dove off the ground? When you're doing these problems, I suggest you always start by drawing the ground. And we will always assume that the ground is flat and level. That there aren't any hills and it doesn't go uphill or anything like that. That's the first thing. Okay, then we need to have James someplace. If you want to just use a dot for that, that's fine. I usually, because I find it amusing to draw them, I usually use stick figures. Notice James is on the ground. And then we need a building. So I'm going to draw a building over here. And he sees a dove on top of the building. And because I drew a stick figure, I also drew a stick bird, like kindergartners draw. Again, mostly because I find it amusing. If you're not amused by it, don't worry about it. And then we need, well, where is the angle of elevation? So the angle of elevation starts from, he looks straight ahead first, and then he looks up. You always start with the straight ahead. The angle in between those two dotted lines is your angle of elevation. This is 67 degrees. Now, before we go on, I'm going to point out that this triangle isn't really on the ground, is it? There's this gap here where his eye is above the ground. To make these problems easier, we're just going to ignore that. If we wanted to get a better answer, we would have to figure out how high his eye is off the ground and add that in at the end of the problem. Okay? It says he is 100 feet from the base of the building. This is the base of the building. Here he is. This is 100 feet. Occasionally I have students have difficulty placing that. The base is on the ground, he's on the ground, this distance is 100 feet. It says he, being James, is 100 feet from the base of the building. So in between those two is 100 feet. And we want to know, how high is the dove off the ground? Well, I'm going to call this D for dove. You don't have to. You can call it X. You can be boring. But why call everything X? I mean, just because your algebra book did? Algebra textbook authors are boring people. Not all of them. Okay, yeah, most of them. So use a representative variable. The further you go in math, the less often they just use X for everything. They almost always use representative variables. Mostly because the problems become more complicated and there's 3 or 4 different variables going on at the same time. All right, so we will assume also that buildings stand at right angles to the ground, so that's a right angle. Unless you're in Italy and they happen to be near the town of Pisa, we'll assume that buildings are all standing straight up and down. All right, so now we just need to write an equation and solve it. From the 67, D is opposite and 100 is adjacent, so that's tangent. The tangent of 67 is equal to D over 100. Put that over 1 and cross multiply. We get D is 100 times the tangent of 67. I think it's better if you write the number first and then the tangent or the sine or the cosine, because then it's more like what you're kind of used to. From there, we just need to grab a calculator. Need to wake mine up. Make sure it's still in degree mode. It is. So 100 tangent 67. $235, and it didn't say what to round it to in this problem, did it? If it doesn't say, then you can round it if you like, but since this was given just to a whole number, I'm going to round this to the nearest whole number. So it's about 236 feet. If the instructions don't say what to round it to, you're free to round it however you like. By the way, on quizzes and tests, it will always say somewhere. And just as a reminder, I had some people yesterday that were asking about, okay, which is the tens place, which is the hundreds place? Just think about how many zeros are in the number. How many zeros are in 10? There's 1. It's 1 place after the decimal. How many zeros are in 100? 2. So it's 2 places after the decimal. All right. Let's do another one. So, in a battle simulation, Kira stands on a castle's parapet 12 meters above the ground. She sees an enemy spy at an angle of depression of 35 degrees. In order to hit the spy with an arrow, how far must the arrow travel? And how far is the spy from the base of the parapet? So they're asking 2 different things. Now, what I get more often than anything else on this problem is, what the heck is a parapet? It doesn't matter. You don't need to know. If you want to look it up, it's fine. But you don't have to know what it is. you need to know that Kira's 12 meters off the ground. Okay, so she's way up in the air. And you can put her on the left or on the right, it doesn't matter. I usually put my observers on the left. I don't know why, I always have. It's not important. So that's her bow, in case you were wondering what the heck that is. Like I said, it amuses me to draw stick figures. Stick airplanes, stick helicopters, all that kind of stuff. All right, so she's up here and she's 12 meters above the ground. Then we have this enemy spy at an angle of depression of 35 degrees. So the spy is on the ground because she's got to look down to see the spy. So again, the angle of depression, you look straight ahead and then she looks down. That's 35 degrees. We will assume that any structures are at right angles to the ground. We want to know two things. How far must the arrow travel? Well, the arrow is going straight from Kira to the spy. So I'm going to call that A. And we also want to know how far is the spy from the base of the parapet. So from the spy to the base of the parapet, I'm going to call that S for spy. And as I told you earlier, the angle of depression is the same size as the angle of elevation. It's all about perspective. If the hero of the story was the spy, we would tell you about the spy sees someone up here at an angle of elevation of 35 degrees. It's just a matter of perspective. But those two angles will always be the same. Whatever you do, don't put the 35 here. You will get the wrong answer every time. And since it's set up wrong, the whole thing's kind of wrong. You don't want that to happen to you. All right, so for A, which side of this right triangle is A? It's the hypotenuse. And 12 from here is the opposite. So I'm going to use sine. Sine of 35 is equal to the opposite over the hypotenuse, 12 over A. Put that over 1 and cross multiply, and I get 12 is equal to A times the sine of 35. We'll divide both sides by the sine of 35. So this would be 12 divided, no, what the heck? 12 divided by the sine of 35. It's about 21 meters. Now, if we want to find out how far the spy is from the base of the parapet, well, that's the adjacent leg. So I'm going to go back to this. I don't want to use A because I've rounded that off. It's a bad idea to use a rounded answer to find something else. So I've got opposite and adjacent. That's tangent again. Tangent of 35 is equal to 12 over S. Put that over 1 and cross multiply. I get 12 is equal to S times the tangent of 35. We'll divide both sides by the tangent of 35. And we get that it's about 17 meters. On this problem, I'll point out again that your answers should be reasonable for what you have. Remember that the hypotenuse has to be the biggest side in a triangle. If you got that this side was 8 or something, you know that's wrong. Also, if this angle is 35, this angle is 55, the smallest angle is 35, the shortest side is across from that. Remember, the shortest side of a triangle is across from the smallest angle, and the longest side is across from the biggest angle, which in a right triangle is always going to be the hypotenuse. Yes, ma'am? You would write, I lost you right there. You would write what? On this, since it didn't say what to round it to, I would write an approximately equal to let everyone know. If it tells you what to round it to, you can put a regular equal sign and that's okay. Because it told you what to round it to, so you're saying this is my answer rounded to whatever the problem said to do. It's a good question. Any other questions? Okay, your assignment is in the book. It's not a terribly long assignment, so have at it.